Hello, welcome back to another lesson on GCSE physics. Today we are going to be looking at how static electricity builds up. Now the first thing that I would like to do, as we quite often do start with our lessons in this way, I would like to complete this fish, dog, elephant task for me please. Obviously pause the video, answer the questions on some paper and then restart the video to mark your work. So the first question was the fish question, which is what is the national grid? That's what we looked at in the last video. Well, you should remember that the national grid is a system of cables and transformers that connects power stations to consumers. Please note that if you've said that anything about pylons being a part of the national grid, then that will lose you that mark. Okay, then we was asking for the colours of the different wires inside a plug. The live wire is of course a brown wire, the neutral wire is a blue wire, and the earth wire is green and yellow stripes. And then finally you were asked to draw the circuit symbol for the LDR. That's something that we did quite a long time ago now. So to do that you would have drawn a normal resistor, then you would have put a circle around that resistor and two arrows going towards it on the left hand side representing light going towards it. Excellent. Okay, so to understand how static electricity builds up, we first of all need to just refresh our ideas of the structure of an atom. You'll remember, of course, that an atom is made up of a nucleus that has protons and neutrons inside of it, and surrounding the nucleus is electrons on shells or energy levels. Now, protons have a relative charge of +1, neutrons have a relative charge of 0, and electrons have a relative charge of -1. Now, it's the electrons that are the most important thing when it comes to carrying a charge, because realistically, if you wanted to try and charge an atom, getting rid of a proton is very, very difficult because it's buried deep within inside the nucleus of an atom, whereas it's relatively easy to lose an electron or for an atom to gain an electron. When an atom gains or loses an electron, we say that it has become an ion. Now, an insulator, something like plastic, can become charged if it gains or loses electrons. Now, if the insulator gains electrons, because electrons are negatively charged, the insulator would then itself be negatively charged. Likewise, if an insulator loses electrons, then it becomes positively charged because it has lost some of the negative charge that it had. Now, this charging process can happen by rubbing an insulator with another insulator, such as rubbing a piece of plastic with wool or cloth, and when that happens, the friction between the two insulators causes electrons to be transferred. Now, I would have normally done a demonstration with you of this in class. You can hang two insulators, or one insulator rather, from a stand and string so that it's free to move, and then charge up another insulator that you hold in your hand. You charge them, of course, by rubbing them with a cloth, which causes electrons to be transferred. And then you can take that insulator near the one that's hanging from the string, and one of two things will happen. Either the insulator that's hanging from the string will move away from it because it's experiencing a repulsive force. That happens when the two insulators have the same charge, so two negative charges would repel each other. Or you might find that the insulators actually move towards each other and they are attracted to each other. That happens when one of them is positively charged and one of them is negatively charged. Okay, a little task for you to have a go at. I want you to explain why sometimes you get an electric shock when you get out of a car seat and touch the door handle to close the door. Pause the video, have a go at answering the question, and then we will discuss it. So you are asked, why is it that sometimes you get an electric shock when you get out of a car seat and touch the door handle? Well, during the journey, you or your clothing will have been rubbing against the car seat. And when two surfaces rub against each other, there is a frictional force present. And that frictional force can cause electrons to be transferred between you and the seat. It doesn't matter in this case if you say that the electrons go from the seat onto you, or if you say that the electrons go from you onto the seat, it doesn't matter. Now, because of that, you are then charged. So when you step out of the car and touch the door handle, there is a potential difference between you and the door handle when you touch it. As you know, when there is a potential difference, that causes a current to flow, so the electrons will transfer from you to the door handle or vice versa, and that earths the charge. Okay, what I'd like you to have a go at now, please, is some exam questions. The exam questions will appear on these slides, so by all means pause the video at the start of each question and then have a go at it, and then I will discuss the answers with you. So the first exam question says, Figure 1 shows a slide in a child's playground. A child of mass 18 kilograms goes down the slide. The speed of the child at the bottom of the slide is 4 meters per second, and we've been asked to calculate the kinetic energy of the child at the bottom of the slide. To begin this, we need to recall off the top of our heads what the equation for kinetic energy is, and you should remember that it's kinetic energy equals a half multiplied by mass multiplied by velocity squared. Velocity is of course speed in a certain direction. Now we need to substitute the numbers into that equation. So the mass we've been told is 18 and the velocity is 4. So we'll do a half multiplied by 18 multiplied by 4 squared, and when you put that into your calculator you should come out with an answer of 144 joules. Okay, 1b. The slide is made out of plastic. The child becomes electrically charged when he goes down the slide. Explain why. So this is a very similar question to what we looked at with the child with getting out of a car seat. So when the child goes down the slide, there is friction between the child and the slide, and that is going to cause electrons to be transferred between them. So you can say, to get the marks, 1 mark for saying electrons are transferred from the slide to the child, or the other way around, and then the second mark is for saying that happens because of friction between the slide and the child. Please note though that it's not enough to get that second mark if you just say because of friction. You need to be specific about where the friction is, because the child is obviously moving over the slide and they are two surfaces that are moving past each other and touching each other. That is where the friction is. So you would need to say it's because of friction between the slide and the child. The next question says, going down the slide causes the child's hair to stand on end. What conclusion about the electric charge on the child's hair can be made from this observation? And give a reason for your answer. So because the hair is standing on end, that means obviously the hairs are repelling each other, and that can only happen if they've got the same charge. So either all the hairs are negatively charged or all the hairs are positively charged, and the reason for that is that they are repelling each other. Then the last question for today says, why would the child not become electrically charged if the slide was made from metal? Well, only insulators can become charged. Metals cannot become charged because charge can move through them because they have free electrons. So the answer to the question is that either metal is not an insulator or charge would flow through the slide down to the earth. Either of those points will get you that mark.